All right, lesson 5.1 is on polynomial functions. So we're moving away from quadratic functions. And of course, we started the year with linear functions. We've also done absolute value functions. Now we're moving on to polynomial functions of bigger degrees than 2. We'll be looking at cubics, quartics, quintics, and well, we'll do some that are to the 6th power. But for the most part, we're going to be looking at the graphs of something that has x to the, say, 3rd, 4th, 5th as its lead term. So what I have down below here is just a chart that tells you what you're looking at. You're going to be on the test, you're going to want to be able to classify by degree. And when you classify by degree, you're just looking for the biggest exponent. So whatever the biggest exponent is, that tells you what it is. So here, there isn't an x term. So that's why you'd say the degree is 0 and you have a constant. Here I have x to the 1st. Degree is 1. That's linear. That's what we started the year off with. Here I got x squared. When you have a 2 for a degree, that's quadratic, and you can read the rest. Up above here, I have a problem that you might think is quadratic, but it's not in the right order. So another thing you'll do on the test is rewrite things in order of degree. So this one on the right is the rearrangement of the one on the left, where I've got negative 3x to the 4th as my lead term, really. So what are we doing? Classify by degree and number of terms. I didn't discuss number of terms. That's over here. Here I had 5. That's only one term, so that's a monomial. Here I have x plus 4. That's 2 terms, so that's a binomial, like a bicycle has 2 wheels. And then 3 terms is a trinomial, like a tricycle has 3 wheels. So example 1, this in standard form would be negative 4x to the 3rd plus 3x squared plus 1. So my lead coefficient is negative 4. That's the number in front. We'll discuss how that comes into play later. The degree is 3. So the degree is 3. That's the biggest exponent. Since the degree is 3, that tells me it's a cubic. There are 3 terms. So it's a trinomial. This is a cubic trinomial. Example 2. In standard form, it would be negative 6x to the 4th plus 5x. It has a degree of 4. That's the biggest exponent. And that is quartic. Quartic, there are 4 quarts in a gallon. There are 4 quarters in a game, so it's quartic. How many terms are there? There are 2 terms, so that means it's a binomial. This is an example of a quartic binomial. The rest of this other stuff we looked at in class as far as putting it in our graphing calculator and just seeing how these are related. Not really a part of this assignment. It was just going to help us move on to the next section. So I'm going to go ahead and move on to the next section. So we were evaluating some differences between, saying, having a 2x to the 3rd and a negative 2x to the 3rd in front, or a 3x to the 4th and a negative 3x to the 4th. And those differences are covered on the next page. So I'm going to go ahead and turn. Those differences give us the end behavior of a polynomial. End behavior is what happens at the ends. So I'm just going to make a little quick sketch here. Say I had this shape over here. I don't know what that is. It's got some hills and valleys in it. I don't know how to get all this middle stuff off the top of my head here. But I do know what the end behavior tells me. And the end behavior is right here on the left and right here on the right, where the arrows are. Those are the ends. That left arrow is going down, and that right arrow is going up. So this is like a line. This equation, this polynomial function would be like a line. It would have this behavior, where a line that goes up right and down left. Polynomial functions that are like a line have odd degrees. So if you've got x to the 3rd, x to the 5th, x to the 7th, your end behavior is like a line. if the lead coefficient is negative, if the number in front is negative, then the end behavior would be like a line that goes down. Now it says up, down in my notes. Here's my line that goes down. It's up on the left, down on the right. That's why it's called up, down. This is how your book denotes it, as up, down. Now I won't actually use up, down with you guys. We're going to use the pre-calc and higher math terminology. And that's what this is right below. It looks pretty confusing. But once you get the hang of it, it's not real bad. Notice that this is the same on every single example here, or every single explanation. It means the same thing. This means this is read the limit of f of x as x goes to negative infinity. The limit of f of x as x goes to negative infinity. F of x is our function. That's our graph. So up above here, all the squiggle stuff that I add up here, that's our f of x. So here I add f of x looks something like that. The x's on it going to negative infinity means that if I was on this roller coaster and I headed towards negative infinity on the x, that means I'm going left. So as I go left, I'm going left. What happens at the end? What other direction do I go? Well, I'm also going down on the far left. So that's what this means here, that I'm going left. And I'm going left. These are all left. That's what f of x, where x goes to negative infinity, means. X going to negative infinity is to the left. Now the example I was saying up here would be, I'm also going down. Well, that wouldn't match this one because this right here is positive infinity, and that would mean up. These are my y's at the end. So this tells me where it's going up or down. It's positive, so that's up. Over here, this is down because it's negative infinity. And this means right. It means right because x is going to positive infinity. All these are right. This is right. This is right. So when you write these, you would always write each expression that I have here. You don't have to think about it. You have everything in the box, the green boxes written to explain end behavior every time. The things you have to think about are what to put at the end. Is it up or down? So when I have a line right here that goes up to the left and down to the right, this is how I write it. I write this up here and down here, negative infinity. My next one, I've got a coefficient that's positive. So my end behavior is down and up. That means it's like a line that goes up. So as I go to the left, I go down. And as I go to the right, I go up. Positive infinity is up, negative infinity is down. Those are if I have x to the first, x to the third, x to the fifth, x to the seventh, that type of thing. The next set I've got is polynomial functions that have an even degree, like x squared, x to the fourth, x to the sixth, x to the eighth. Those are like parabolas, because you get a parabola by doing y equals x squared, which is even. Well, if I have a lead coefficient that's negative, the end behavior is down and down because it's like a parabola that goes down. And on the left-hand side, I'm going down, and on the right-hand side, I'm going down. So this stuff here is another way of saying left down and right down. Limit of f of x goes to as x goes to negative infinity equals negative infinity means left down. The limit of f of x as x goes to positive infinity equals negative infinity equals right down. My last one would be where I have a lead coefficient that's positive. End behavior is up and up. So here I've got an even with lead coefficients positive. It's like a parabola that goes up. So it would be left up, right up. But the good mathematical way, the proper way to write it would be like that. Okay, so determine the end behavior. How does it work? Just look at this first term. Because it's got the biggest power, it's got the 6. Because it's 6, that's even. So think parabola. -2, so think down. The lead coefficient is -2, so think down. So we're trying to describe a shape that goes down on the left and down on the right. There's some squiggles in the middle, some turns. But I know on the far left and on the far right it goes down. Well, how do you do that? You write LIM, limit of f of x, as x goes to -infinity, equals, as I go to the left, I'm also going down. And this is how you write down -infinity. Then you write limit, as x goes to +infinity of f of x. Always write that same thing. That means I'm looking at the right. That would also be -infinity. And that's how you describe end behavior like a professional. In your book, it would simply say down and down. -infinity and -infinity is down and down. Next one, a little bit tricky because it's not in standard form. You actually should focus in on the -3x to the 5th because that's got the biggest power. And because it's a 5, that's odd. 5 is odd. So think line. The lead coefficient is -3. That's less than 0. So think down. So I'm thinking about a line that goes down. And I'm going to describe end behavior of that line that goes down. Again, I just go ahead and write limit of f of x as x goes to -infinity. And I write limit of f of x as x goes to +infinity. And look how where I got the x going to. It's under the limit. It doesn't go under the f of x, just under the limit. I want to know what they equal. Well, left is also up. So this is left over here. Up is +infinity. Right is down. So this is right over here. That's -infinity. That's how you do end behavior. Okay, then we got turning points. Turning points, how many curves do you have in a graph? Well, the number of curves you can have in a graph are based on the degree. And here the degree is 6. So that tells me that I could have as many as 5 turns. 5 turns, because that's 1 less than 6. Now, it doesn't have to be 5 turns. It could be 3 turns or it could be 1 turn. It has to be odd when you start with an even degree. Now, what I did was plug these into a graphing calculator and make a table. And I'm going to test my memory here. When you plug in -2, I think it's -181. When you plug in -1, I get -4. 0 is obviously -5 because everything cancels with the -5. That's -4, -181. Sketch a graph of this. You can look at it in your graphing calculator. This is 6, so it's like a parabola. And it's negative in front, so it's like a parabola, it opens down. So you've got -2, you got to go way down. I've got 0, -5, like this. I got -1, 4, and this is what goes on here. Makes an M. Now this one could have had 5 turning points, but it doesn't. It actually only has 1, 2, 3 turning points, which is okay. It could have had a 5, 3, or 1, but it could have had up to 5. I'm pretty confident that there aren't any extra turning points that I missed, that they're not off the screen of my graphing calculator. Just because it went from -4 to -181 like that, that tells me this thing is plunging and it's not likely that it's going to come back up. In your assignment, you had something like this. Determine the possible degree of that. Well, I know that looking at this is like a line that goes up. So this would have an odd degree. So it'd be x to the 1st, 3rd, 5th, 7th, something like that. Now I'm just going to count turning points, and you're going to come up with the least degree. So I got 1, 2, 3, 4 turning points. That tells me that the least degree can be x to the 5th because you go 1 less than that. It could be x to the 7th, but that's not the smallest degree. So when you have 4 turning points, that means that you have an odd degree. If you have an even number of turning points, you have an odd degree. If you have an odd number of turning points, you have an even degree. Okay, and then the last thing, you're going to figure out the degree of the polynomial that gets you this list of numbers. This is kind of cool. All you do is subtract a number from a number minus what's below it. So -1 minus -7, that's 6. -7 minus -3, -4. -3 minus 5 is -8. 5 minus 11 is -6. 11 minus 9 is 2. 9 minus -7 is 16. And you go until, this is called the first difference. You go until you come up with all the same numbers. So we've got to go again. 6 minus -4 is 10. -4 minus -8 is 4. -8 minus -6 is -2. -6 minus 2 is -8. 2 minus -16 is 18. And taking a look here, I think I got a boo-boo. Oh, 9 minus -7 is positive 16. Don't know why I have a negative. So we got to go backwards here. 2 minus 16, -14. There we go. Second difference didn't work. It did not give me all the same, so I got to go again. I'm going to go to the third difference. 10 minus 4 is 6. 4 minus -2 is 6. -2 minus -8 is 6. -8 minus -14 is 6. Now they're all the same. That tells me that this function right here is something with x to the third. It's a cubic. Because it took me 3 times, 3 subtractions, to get all the same. If it took me 4, it would have been to the 4th, quartic. If it had taken me 5, it would have been to the 5th, quintic. So, a lot of material in this lesson. We'll be discussing it throughout the chapter. Thanks for watching. Have a great day.